right. My name is Danielle Gillum. I am here to present to you this presentation on these 6 questions. Okay, let's begin this. All right, this is for my Math for Teachers 1 class. All right, so first question is, you want to place the digits 8, 10, 11, 12, and 13 in circles to make sure the sums across and vertically are equal to 31. So they're going to have to go this way and this way to equal 31. So I started out with 8 being the lowest number, and then I worked my way to where it was with the lowest number next to 8 and the highest number of the digits. And so when I did that, 10 plus 8 plus 13 equals 31, and 11 plus 8 plus 12 equals 31. And I tried to play around with it, and in order to make the puzzle with the digits 8, 10, 11, 12, and 13, I had to, like I said, place the numbers to make the sums across and vertically equal 31. So after I filled the puzzle in with those digits, I then checked my work to see if there could possibly be any more answers. And the answer is technically no, but you can interchange the numbers on the top and left bottom on the left and right to rotate the whole puzzle. Let me show you. So basically, if we flip-flop 10 and 13 and 11 and 12, it's still going to be 31 and 31. If you would rotate the whole puzzle to where 10 was right here and 13 was right here, then it's 31 and 31 again. And so that's the only technicality to the answer no. Second question is, there are 9 square tiles laid out on a table so that they make a solid pattern. Each tile must touch at least one other tile along an entire edge. See the 2 examples below. The squares all have sides of length of 1. So basically, this right here is a 1, this right here is a 1, here is a 1. So these 3 together are 3s. So the perimeter of this one is 16 units by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. This one was 18 by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So that's how I got my perimeters. And these 9 square tiles can make multiple patterns. So if I did it like this, oops, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the perimeter is 12. This right here has a perimeter of 18. So the possible perimeters after drawing out all the figures were going to be like, you were going to get a perimeter of 12, 14, 16, 18, and 20 units. Therefore, the figure with the least perimeter has a perimeter of 12 units, and the highest would be 20. All right, number 3. So the triangular numbers and these square numbers are shown below. So this says 1 dot, 3 dots, 6 dots, and 10. This is 1, 4, 9, and 16. And right here are the sequence of dot patterns to complete part A through C that we're going to be working on. And then it has a couple of equations that we will be using. And let's go on to the next page. Okay, so it told me to draw the next two figures after these. So as you can see, the sequence have 2, and then to make a pentagon, it added on some. Oops. And it kept adding so on. So these were my two figures that I drew to make the pentagon. And on the B section, it said to list the number of sequence of patterns that correspond to the sequence of pattern A. These are called pentagon all numbers. So to get these numbers, like I said, we counted here was 2, and then there was 6, and then the next two were 13 and 22, 13 and 22, and the ones I drew right here had 34 and 48. So that's how we got those. So then you're going to add 4 more equations to the list. The equations are suggested by parts A and B. This is another new math equation, but it runs along with it. So you start out with 1 equals 1, and then you add more. So 1 plus 4 is 5, and then you're adding 3 each time, it looks like. So 1 plus 4 plus 7, 12. Add 3, add 3, add 3, but you're adding the total number. So it's 1 plus 4 plus 7 plus 10 equals 22. So then it told me to do the 4 more equations. So it's going to be 1 plus 4 plus 7 plus 10 plus 13 equals 35. And then you're going to do that equation 2 again, plus you'll add 3 more than the last number, so 16, 51. Add 3 more to the last one, it will be a 19. Equals 70, and then to the 19, 3 more than that is 22, so you add 22 to the last equation that you had. 70 plus 22 is 92. So that's how we did those. All right. Question D, observe that each pentagonal number is the sum of an arithmetic progression. You're going to compute the 10th term and the arithmetic progression 1, 4, 7, and then 10. So for the 10th term, I had to add up 10 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it started with 1, 4, 7, and 10. And again, it looks like we're adding in 3s. So 3 numbers after 10 would be 13, add 3 again, it's going to be 16, 3 again, 19, 22, 25, 28, as you can see. So after we add up all those numbers, it is going to be 145. So the 10th term in the arithmetic progression equals 145. So then it says to show the formula for pentagonal numbers and calculate the 9th and 10th terms. So this is the pentagonal formula. So to get the 9th and 10th terms, you are going to plug in for the 9th one, T9, because 9 is the n, equals 9 times n plus 1 divided by 2. And for the 10th one, it will be the same thing. N equals 10, so T10 equals 10 times 10 plus 1, in parentheses, sorry, divided by 2. And so that's going to be for any nth term. You're going to use whatever number is given for the nth term, put it in place of n, and that's how you're going to get your equation. I love these. I am a big Sudoku fan, so I feel like this is kind of like a puzzle like Sudoku and all these puzzles that I do on my phone for fun. So it said for each number is the sum of the two numbers immediately below. For each of the incomplete addition, the unknown variable shown, write an equation to solve each pyramid, show each step used to solve each equation. So this is the box that was given. So you're trying to find x, which sorry, this equation was made easy because 7 was given, your middle number right here was given. So what you're doing is you're adding these two numbers to get this number, these two numbers to get this number, and then your middle two are going to equal your top of your pyramid. So since 7 was given, 7 plus 3 equals 10, so that's how we got that. And then your 25 minus 10 equals 15. So this will be 15 because your 15 plus 10 will equal 25, just to check it. And then your 15 minus 7 equals 8. Therefore, x is going to equal 8. And then I filled it out down here. So then we got a trickier one. So you kind of had to just play around with it. So I started with your common addition numbers for 15. A lot of people use 8 and 7. So I started with that. So I tried to do 15 minus 8 equals 7. So 8 and 7. And then we'll see from there. So 8 minus 1 equals 7. And then 7, or sorry, 8 minus 2 equals 6, and then 7 minus 1 equals 6. So therefore your y is going to be 6. Sorry, I mixed those up. So yes, that's how I found that. So your 7 would be right here, and your 8 would be right here, and it makes a difference because you're 2 and you're 1. So then for C, there is 27, Z, 2, and 9. That's what was given. So I put 7 in the bottom middle box and then tried it from there. So your 7 plus 9 equals 16. So I got 16 there. 7 plus 2 equals 9. And 9 plus 16 equals 27. So therefore, Z was 9 right here. Oh, this was fun. So it's just the process of trying to find something, eliminating things. So you have 4 married couples belong to a bridge club. The wives' names are Kitty, Sarah, Josie, and Anne. The husbands' names are David, Will, Gus, and Floyd. Use the table below to sort out who is married to whom. Just want to make sure I'm still recording. Okay, so Floyd is Josie's brother. So Josie will not be married to Floyd, obviously. So I put it, it's there. And then Kitty is married to Will. That is automatically known thing. Oh wait, sorry. Josie and Gus dated some, but then Gus met his present wife. So that is just giving a wife that Josie and Gus are not married. And then we have the Kitty is married to Will. So a check on that. We know they are married. So that this X represents that Anne has 2 brothers. It's really not very good information, but Anne's husband is an only child, and we know that Floyd has a sister named Josie, so he is not an only child, so therefore Anne is not married to Floyd. So then, since Kitty's married to Will, we know she's not married to David or Floyd or Gus. And then we know that the only one left for Floyd was Sarah. So Sarah and Floyd are married. So she's not married to David or Will or Gus. So then Anne, for Gus's option, was the only one was Anne. So Anne is married to Gus, who is an only child. So therefore, Josie can't be married to Will because Kitty is. And Will is not married to Anne because he's married to Kitty. So Anne's not married to David because she is married to Gus. So that leaves with Josie and David is married. So we have Kitty and Will are a couple. Sarah and Floyd are a couple. Josie and David, and Anne and Gus. Number 6. Consider the trapezoidal numbers 1 plus 1 plus 1. You got 1 plus 2 plus 2 plus 2 plus 1. 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. The nth trapezoidal number is 1 plus 2 plus blank plus n plus n plus n plus blank plus 2 plus 1, where n is a positive integer. So to create a dot pattern representation of the trapezoidal numbers, so 1 plus 1 plus 1, and then you have 1 plus 2 plus 2 plus 2 plus 1, and then we have 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. So that's how we got those. Alright, so you'll notice that these equations are there. So the 1 plus 1 plus 1 equals 1 times 3. And then the 1 plus 2 plus 2 plus 2 plus 1 equals your 2 times 4. And then your 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 equals 3 times 5. So you're going to show how the dots in a representation of a trapezoidal number can be rearranged into a rectangle with 2 more columns than rows. So this one right here is what we had right here. It is your 1 plus 2 plus 2 plus 2 plus 1 partial pyramid. And then they are rearranged to the rectangle. So basically all that was done was this one was moved over here. And it makes a rectangle with, there are 2 rows, and there are 2 more columns than rows, so it's going to be 4. So that's how you figure out how to move those together. So then it said use inductive reasoning. Show what general formula gives the nth trapezoidal number. The general formula is Tn equals n times n plus 2. For example, the equation of 1 plus 1 plus 1 equals 1 times 3 is, we're going to put 1 in place of the nth place. So T1 equals the 1 plus 1 plus 1, which we just found out and we already knew was 1 times 3. And then to apply it to the equation, it is going to be 1 times 1 plus 2 in parentheses. So that's all. Thank you for learning with me. I enjoyed it, and thank you very much. I hope we get to meet again.